So let's look at what we have here. So find the second degree Taylor polynomial centered at x equals 0 for f of x is equal to e to the x power. So some things that we know, we have a second degree, so that means n is equal to 2. We are centered at x equals 0, so c is equal to 0. So this is a Maclaurin polynomial, and f of x is equal to e to the x. A second degree Taylor polynomial will look like p sub 2 of x equals a sub 0 plus a sub 1 times x plus a sub 2 times x squared. So now what we need to do is figure out what these coefficients are. So we need to figure out a sub 0, a sub 1, and a sub 2. And we're going to do that by kind of matching some things up. So if I plug in 0 for x of our function, that has to equal the exact same thing as our 0 for our polynomial. So we need to match the point. So whatever our y value is, whenever our x value is 0, we have to match that our y values are the same for both. So match the point p sub 2 of 0 equals f of 0. And then we need to do that for the first derivative. So we need to match the slope p sub 2 prime of 0 equals f prime of 0. And we need to do that for the second derivative. So p sub 2 double prime is equal to f double prime of 0. So these are all at our center. So that's a really big thing here, and we're using that on purpose. And we're doing that so that way our x value kind of goes away and we don't have to worry about it. So let's do the first part. So p sub 2 of 0 would equal a sub 0 plus a sub 1 times 0 plus a sub 2 times 0 squared. The really nice thing about this is that all of those things that have an x are being multiplied by 0, so we get a sub 0. So now what we need is f of 0. So e to the 0 power equals 1. So what I know is that p sub 2 of 0 has to equal f of 0. P sub 2 of 0 equals a naught, or a sub 0, and f of 0 equals 1. So I know a naught has to equal 1. Then we're going to do it for our derivative. So p prime 2 of x, a sub 0 we know is 1. It's a coefficient, so that goes away. The x will go away, so I have a 1 plus, if we use power rule on this right here, 2 goes up front, so I have 2 times a sub 2 times x. We're going to plug in 0 now, so p prime of 0 and thankfully everything else goes away except for a1. So we need to find f prime of x, which is e to the x, and f prime of 0, which is e to the 0. Once again, it equals 1. We know that the derivative of our polynomial at 0 has to equal the derivative of our function at 0. So we're going to set those equal to each other. P prime sub 2 is a sub 1. F prime of 0 is 1, so I know a naught is 1, a sub 1 is 1, and we have our last piece here. So we have one more part here. P double prime of 2 of our function. So we're taking the derivative of what we have above. A sub 1 is a constant, so that goes away, and I'm left with 2a sub 2. If we plug in 0, it's going to leave us with the exact same thing. So 2a sub 2. We need to find the second derivative of e to the x, which is e to the x, and plug in 0, which equals 1. And then once again, we are going to take our second derivative of our polynomial at our point 0 and has to equal our second derivative of our function at 0. Well, this time we have 2 a sub 2 is equal to 1, and we need to solve for a sub 2. So a sub 2 is equal to 1/2. I have all the parts and pieces that I need for my function because I now know what a sub 2 is, I know what a sub 1 and a sub naught is, or a sub 0. So I'm going to take those values and plug it back into our function. So our second degree Taylor polynomial is p sub 2 of x equals a sub naught, or a sub 0, which we know is 1, plus a sub 1 times x plus a sub 2 times x squared. So you're going to notice our first degree Taylor polynomial is already there. We have now just added another term. So this kind of gets a little tedious. So what we're going to do in a little bit is we are going to figure out how do we get these coefficients in a faster way, because I can't do this for sub n. That is just too much, and the tediousness of what we already did is a lot. So what we're going to do in a little bit is figure out how do we do this in a more efficient way.